Hello guys, welcome to today's lecture on decision trees and random forest. So basically I'll be walking you through development of a decision tree and a random forest classifier. Now a decision tree is more or less like a standalone tree. From the name you can tell it's a tree, just one tree. But then the random forest comprises of various trees, and it is actually and usually makes better prediction than the tree because two heads are better than one. So here I import my data set. I import the libraries, and as I said in the previous video, that I'm going to be using the ABT Titanic for the rest of the course and classification. I run this, and then I want to print the shape, then see the head. Right, so I can see actually this data has been cleaned. We cleaned it. Yeah, we did that. Right. Check the data info to ensure no missing data, and then we'll move on to train test split. From SQL model selection, we import train test split, and we do the same thing we did in the previous class, which is selecting the feature, which is going to be called X, and then the target, which is going to be called Y. And I run this, and then we use the train test split function to split the X and Y using the test size to be 30%, which means the Y test and the S test are taking 30% of the data. Meanwhile, the X chain and Y chain are taking the remaining 70% of the data. Sorry. We are doing this so we are allowing the training set to have more data so that it can have enough data to train on and more instances to learn from. So after doing this, we import our decision tree classifier from sklearn.tree. Then after running that, we instantiate, just as we have been doing, the tree decision tree classifier, blah blah blah. Decision tree actually takes in some arguments, but then we are not going into hyperparameter tuning for now. We'll come to that when we get to the end of the class, when we ensure that we already understand how to build most of these classifiers. So then we fit our data set, we fit and train our data set, then prediction, to make prediction and evaluate our models. So prediction d3 dot predict s test, and we call it prediction here. So don't mistake it, don't make a mistake and don't mix it up. So we import our metrics, what we are going to check, the metrics we want to check in our classifier, which is confusion matrix, accuracy score, classification report. So we do that, you check our classification report, and you see that our classifier actually performed very bad. I think worse than the logistic regression from the last class. And let's check the confusion matrix, and I see it's worse. As you can see, it's very worse, very bad. 37 and 32. This is like 69, and the logistic regression was 53. Then let's see how it goes. So logistic regression accuracy was 80%. Meanwhile, on the same data set, the decision tree gave us 74% accuracy. So we move on from here, and we go into the random forest. And this is random forest. We are not specifying the trees we are bringing into our forest. But then, so we do the same thing from sklearn.ensemble. We import random forest classifier. Then the random forest classifier, we instantiate it, and then number of estimators is 100. Number of estimators actually depicts the number of trees we are using. So we are using 100 trees here to train our forest. Then we'll run this. Then we'll do this, we predict. I believe you understand all the syntax already. If you have any question, you can always hit me up and leave a comment down below. Check classification report and then confusion matrix. Now let me check the accuracy score, so we know whether this performs better or not. Accuracy underscore score Alright, so this actually performs almost as well as the logistic regression, 80% as well, as you can see. So you can tell that if we should tune the hyperparameters of this model, we can get something out of it. But from what I can see, I don't think it's the best model for us to use for it to be having 80% at this point in time. Probably have to do a lot of work to get it to perform very well, or probably we are using the wrong classifier for a data set. So basically, this class is done, and I'll see you in the next one.